Hello, everybody. Welcome to the second week of Math 142 Skills Labs. And this week, we're going to be talking about verifying identities. Now, I know that these can be a little tricky sometimes. You're given some of these values and you're not exactly sure how to equate some values. So we're just going to go over a few examples. Maybe you'll be more comfortable writing these proofs about how certain functions, certain trig functions can be rewritten into a simpler form or a different form. So we're going to do 5 examples. Example number 1, we're going to do secant theta minus 1 times secant theta plus 1 equal to tangent squared theta. So this one is fairly easy. All you're going to do is FOIL. So you've got secant squared theta plus secant theta minus secant theta minus 1. And that's what you get when you FOIL, which simplifies into secant squared theta minus 1, which if you look at any trig identity sheet will result in being equal to tangent squared theta. So that's a fairly easy problem just to get us into it, just to see that sometimes these aren't as complicated as they seem. Sometimes it's just one simple step and then you're done. So let's move on to question number 2. Question number 2, we have 1 over 1 minus sine squared theta is equal to 1 plus tangent squared theta. Now, if you look at this and look at any trig identity sheet, you can see that 1 minus sine squared theta is equal to cosine squared theta. So we can rewrite this into 1 over cosine squared theta is equal to 1 plus tangent squared theta. And we know that 1 over cosine is equal to secant, so we know that secant squared theta is equal to 1 plus tangent squared theta. And you can look at your example, oh, secant squared theta minus 1 is equal to tangent squared theta. You can move the 1 just by looking at this example right here and prove that these two are in fact equivalent. So let's move on to question number 3, which is a little bit more tricky. Question number 3 is 1 plus secant x over secant x is equal to sine squared x over 1 minus cosine x. Now what you're going to do is split this up to begin with. There's very easy steps to identify initially when doing any type of trig identity. Some of it is splitting up something. So we see this, we can simplify it into 1 over secant x plus secant x over secant x. And then we want to convert everything to sines and cosines. So we get this to be equivalent to, okay, that's cosine, so cosine x. These cancel, so we end up with 1, so cosine x plus 1. Now, how do we get this to look like this? Well, we can multiply this by 1 minus cosine x over 1 minus cosine x, because when you FOIL these, you'll end up with a 1 minus cosine x here, and so you'll be ending up with 1 minus cosine squared x over 1 minus cosine x. And now that you have this, you can rewrite this top form into simply sine squared, sine squared of x over 1 minus cosine of x. So these are just the first three problems. Hopefully they're helping you understand how to work through these problems. We're going to start on our next set of problems, which are problems 4 and 5. Problem 4 is 1 minus tangent x times 1 minus cotangent of x is equal to 2 minus secant cosecant of x. So now let's look at what we've done in our previous examples and just FOIL this out. So you've got tangent x, cotangent x. Actually, sometimes you can work from the other side, and I forgot that you could do that because that is a little bit harder to FOIL out. So let's just work on this side, the 2 minus secant cosecant x. We can simply replace this with a 1 minus tangent x, 1 minus cotangent x is equal to 1 minus tangent x minus cotangent x plus tangent squared x cotangent squared x. And now that you've got this, you can take some and just sometimes cancel, sometimes just rewrite in terms of sines and cosines. So we end up with a 1 minus sine x over cosine x plus cosine of x over sine x plus 1. Now we can use this and multiply to get a common denominator. And when that occurs, we get 1 minus sine x, sine squared x over sine x cosine x plus cosine squared x over sine x cosine x, or 2, sorry, I miswrote that. And now this is really nice to see because we have a sine squared x plus a cosine squared x, and we can just simplify that into 1. And these bottom parts can be also rewritten into a simpler form. So when we have this down to 2 minus 1 over sine x cosine x, we can split it back up again and rewrite it into 2 minus secant cosecant x. And I know I didn't explain this thoroughly in the beginning. I sometimes get confused with this as well. So what I ended up doing is just, using some identities to come figure out this first step. And from then you can just rewrite and rewrite. And it's very helpful to initially write things in terms of sines and cosines until you can prove that the identities are equivalent. I know that was a little bit confusing. It was confusing a little bit for me too to work that out. So anyway, we can just move on, and I hope that example is also helpful for you guys. So let's look at this example. Cosine of x plus y over cosine x sine y is equal to cotangent y minus tangent x. So this is interesting. So one thing we can do is use the properties of adding in between the numbers that we used in half angle, double angle identities, and we can use that to help us solve this. So let's use that. So we have cosine x cosine y minus sine x sine y over this, which is cosine x sine y. And now that we have that, we can split this up. And I know this looks like a thing, but it's a sine y, I promise. So let's split this up. Cosine x cosine y over cosine x sine y minus sine x sine y over cosine x sine y. And then we can cancel the sine y's and the cosine x. So now we've got cosine y over sine y minus sine x over cosine x. And if you know tangent and cotangent, you can know, oh, this is just simply equal to cotangent y minus tangent of x. Now, I hope these examples were helpful for you in learning how to do identities. Sometimes they can be complicated, like in example 4, and sometimes they can be easy, like in example 1, where you just have to factor, and sometimes that's just the easy step. So I hope this video was helpful for you guys. I hope you guys continue practicing these identity problems. I hope that you guys will, keep working hard, stay motivated, and yeah, I hope that you guys have a great weekend and do well on your test.